This video is about canceling repeated values, part 2. So it's going to be very similar to the strategy we used the last video, except we're going to add a little bit of complexity. So everything's going to stay the same except for step 2. Instead of just saying we're going to multiply by 1 for the bottom equation, we're going to say we're going to multiply by 1, 10, 100, etc. And that is going to be for the bottom equation so that the decimal value, the decimal point, is next to the repeated value. And I know this is kind of a long point now, and what does this mean exactly? And so I think the best way to explain that is to actually go through an example. So that's what we're going to do right now. We're going to look at a couple examples like this. So the first example we're going to look at is going to be 2.08, and the 8 is what repeats. So this number would look like 2.08888 forever and ever. And so how do we get rid of the decimal in this case? So same as last time, we set up the algebra equations. And so when I do that, I'm going to have x equals and x equals. But this time, instead of automatically multiplying by 1, we actually have to pay attention. So if the 8 was next to the decimal place, so if it was like 2.8 like this, repeating, we would multiply by 1 because it's already right next to the decimal place. But in this case, it's actually removed from the decimal place slightly. Notice how it's 0.08. And so we actually need to multiply this so the decimal place ends up right next to our repeating value. And so what I really want is I want 20.8 repeating. And so notice how I shifted this decimal place over here. And the reason why I did that is because I want that decimal point right next to my repeated value. And so in order to do that, I had to multiply by moving the decimal place once, which is associated with multiplying by 10. And so we're actually going to say in this case, 10x equals 20.8 repeating. And so just in case if you're wondering, this is our number, right? This is our original number. But the issue with this is my repeated value is not next to the decimal point, and I want that repeated value to be right next to the decimal point. And so that's why I do this. Okay, so step 1 and step 2. Next, we have to worry about step 3, multiply the bottom equation by 10 for the top equation. So we're actually going to follow that exactly the same. And so in this case, I'm going to say 10 times 10 is going to be 100. And then 20.8 repeating times 10, well, this will end up moving my decimal place once to 208.8 repeating, like that. And so all I did is move this decimal place once down, and remember I have to have that 8 repeating afterwards. Next, we're going to subtract the algebra side of the equation. And so when I do this, if I subtract 100 minus 10 this time, instead of like 10 minus 1, we have 100 minus 10. That's going to be 90. Our x doesn't change, equals. And then we have to just subtract my decimal side of the equation. So we're going to subtract the decimal side of the equation. And if I do 208.8 repeating minus 20.8 repeating, the 0.8 repeatings cancel out, and so I'll get 0. And then I have 208 minus 20. Well, let's check that out. 208 minus 20 should give us 188. And it does give us 188. So we end up with 90x equals, and excuse my terrible handwriting, 188.0. Simplifying just a little bit more, 90x equals 188. And this is our final answer for this example. So we're going to go over one more example in this video. And so I'm going to delete this. And our next example is going to be 9.63 repeating, like this. So for this example, we have to set up our algebra equations. So I'm going to have my top equation and my bottom equation. Great. We need to figure out, are we multiplying by 1, 10, or 100 for the bottom equation? So if I look at this, if I want to get to the 3 here, I'm going to have to move my decimal place once and then that's going to have the 3 right next to my decimal point. So in this case, I'm also going to be multiplying by 10. So we're going to say 10x equals, and if I actually multiply this by 10, I get 96.3 repeating. So this is what I want with the decimal place right next to the value, right next to the repeating value. So 10x is 96.3, and we have done that second step. Then I want to multiply the bottom equation by 10 for the top equation. So 10 times 10 is 100, and 96.3 times 10 is going to be 963.3 repeating. Great. Then I want to subtract the algebra side of the equation. So I'm going to do 100 minus 10. That's going to give me 90x equals, and then I'm going to subtract the decimal side of the equation. And to subtract the decimal side of the equation, I have 963.3 repeating minus 96.3 repeating. Of course, my repeating decimal places cancel, just like I want them to. And then I have to do 963 minus 96. Well, I'll just do this one by hand instead of the calculator. So if I do this, this becomes an 8. And then this would become 15 in the end, I guess. And this would become 13. 13 minus 6 should give me 7. 15 minus 9 should give me 6. And then I should have 867.0. Let me just check and make sure I did that right, because that was kind of hard for me. So we'll do 963 minus 96, and that should give me 867. Excellent. So down below a little bit, I'm just going to clean this up. 90x equals 867, dropping the 0.0 because I no longer need that. Awesome. We're going to look at one more example in this video, and that example is going to be 4.007 repeating. Okay, so step 1, we're going to set up our algebra equations, and I'm going to say x equals. We have our 2 algebra equations. Okay, next I need to determine, am I multiplying by 1, 10, or 100? So in this case, to get my decimal point next to it, I need my repeating value next to the decimal point. In order to do that, I'm going to have to multiply by 1 place value, 2 place values in this case. So to move 2 place values, I'm going to multiply by 100. And so this ends up looking like 400.7 repeating. So 4 times 100 is 400, and that kind of makes sense, but you could also think about it as moving the place value twice. And so down here, I'm going to say 400.7 repeating, but this time I actually multiplied by 100. So I'm going to say 100x is 400.7 repeating. So this step is completed. Now notice the difference here. This was new. We had to multiply by 100 because I had to move the place values twice. All right. Now we're going to multiply the bottom equation by 10 for the top equation. And so when I multiply 100 times 10, that's going to give me 1,000. And then if I do 400.7 repeating times 10, I'm going to get 4,007.7 repeating. Next, I'm going to do the subtraction on the algebra side. So I have 1,000x minus 100x. Well, that's going to give me 900x. 1,000 minus 100 is 900. And this is going to equal, on the right-hand side, I'm going to subtract the decimal side of the equation. And I have 4,007.7 repeating minus 400.7. Well, my decimals cancel out like they are supposed to. And then I have 4,007 minus 400. So let's clear this. 4,007 minus 400. That's going to give me 3,607. And cleaning up just a tiny bit, 900x equals 3,607 as our final answer. And that's it for this problem. Okay, I'm going to stop this video here, and we're going to start part 3 in the next video.